So I do occasionally get a few videos talking about what's going to happen after we colonize Mars. And one of the articles say that Titan is going to be our potential chance for another colonization and setting up new habitats. So we'll be discussing why Titan. So let's talk about it. So let's talk about Titan. So Titan is the largest moon of Saturn and the second largest moon of our entire solar system, with a diameter of 5,050 kilometers or 3,200 miles. It is slightly larger than the planet Mercury. Mercury is about 4,879 kilometers or 3,030 miles. So Titan's atmosphere is very similar to Earth, except when it's 4 times denser than Earth's atmosphere, and it's mainly composed of almost the same composition. So, for example, nitrogen. Nitrogen takes up 94.2%, with methane coming at 5.65%. Trace gases are less than 1%. And what are those trace gases? Well, the trace gases is included with hydrogen being 0.099%. So argon is 0.065, carbon monoxide is about 0.0 something. So it's in the trace gases of that less of 1% of its entirety of its atmosphere. So let's talk about Titan's temperature. So the temperature of its surface reaches about 94 Kelvin. Now 94 Kelvin will be translated to negative 179 degrees Celsius or negative 290.2 degrees Fahrenheit. So the composition of Titan, we're going to be also explaining its geography. So Titan is mainly composed of rock and water, right? So most of it is rock, and then the rest of it's primarily ice water and other materials that may have coalesced in the outer reaches of our solar system. Now, it also has a rocky center, and Titan's features are shaped by active methane-based hydrological cycles, and similar in some ways to Earth's water cycles. You know, we have water, we have evaporation, condensation, deposition, all of these parts of the water cycle, you know, that goes on every single day. Titan is composed with equatorial sand dunes made from organic hydrocarbons, lakes and seas, but not water. They're actually made from methane and ethane. Titan does have mountains that are made from ice and hydrocarbons. There's craters on Titan. There's quite a few. We have labyrinths. They're basically disrupted areas, kind of like fissures from tectonic activity. What else? We have hilly mountain areas. So basically, that's pretty much what Titan has. It's actually, the landscape is quite similar to Earth, but just blanketed with a very dense atmosphere. So it's basically taking a look at Earth when Earth went through a massive glaciation period called Snowball Earth. So to really understand the formation process of Titan, so Titan was formed very similar to how the rocky planets were formed. Now Titan was actually formed in the outer reaches of our solar system, right around Saturn. Basically, it was formed the same way due to rocks and ice and gas that was picked up and coalesced, and then all the gases had pretty much come together, and then that's kind of how Titan formed its own atmosphere. But also there is another scientific theory back in 2026 that proposed that Titan was a survivor of a catastrophic collision. And this is the collision that sent another moon closer to Saturn, and that already broke up and formed its own rings. Well, millions of years ago, Saturn may have had an extra moon called Chrysalis. This object, and then there was Titan. And then eventually, since the overcrowding of the placement of the moons, due to also the Saturn's massive gravity, that disrupted the orders of each of the moons. So when you had the two forces, actually being having a bigger force being Saturn, the pull and the rearrangement of each of the moons had changed, and this misplaced Chrysalis and Titan to the point where they smacked each other. And then this collision course smacked Chrysalis towards Saturn, and Chrysalis eventually broken up and then formed Saturn's rings about 100 million years ago. Some theories that suggest that Saturn's rings had came with it billions of years ago, but Saturn's rings are proposed to be very new, only about when the time when dinosaurs roamed Earth. So, the next segment that we're going to be talking about is after seeing a lot of these new articles about one day after Mars, after we terraform Mars and we terraform other worlds, there's things about going to Titan. And the reason why that humans are most likely going to go to Titan after we go to Mars is because Titan is very unique. Because Titan is the largest moon of Saturn and the second largest moon of the entire solar system. But people claim it as a planet, but it's not a planet, it's a moon. It just so happens that it has a very thick atmosphere and has striking similarities that Earth has. You can take a look at Earth when it went through the massive glaciation periods, 700 million years ago of snowball Earth, and compare with Titan. Those things are so similar because of the compositions. Even present day Earth today, Titan has striking similarities to Earth today. But the most evidence that we have is looking at Earth during the snowball Earth phase and compared to Titan, because it's so similar. Because it has a very similar temperature and the composition. Now, Titan has the entire foundation set up. There's just stuff that we need to modify. So 94.2% nitrogen. Earth has 78% nitrogen. Methane has 5.65%. Trace gases are similar to Earth, less than 1%, so including the hydrogen, the argon, the carbon monoxide. These are very tiny trace gases that are taking up less than 1%. That's similar to what Earth has. Earth is less than 1% argon. That's 0.093 argon. Sorry, 0.93 argon. Its surface temperatures are very cold. Negative 179 degrees Celsius or negative 290.2 degrees Fahrenheit. We can fix that because we do have the foundation that we need to pump some greenhouse gases into Titan and are releasing, with water vapor. Water vapor is a very potent greenhouse gas. Let's see. So Titan does have a very dense atmosphere. That means keeping the deadly radiation away, just reflecting it back. We have an ozone layer that does the same thing. Basically, superior long-term habitability of the thick atmosphere and also the hydrocarbons. Titan is mostly composed of the hydrocarbons, similar to Earth, because Earth was formed from the hydrocarbons, all those little microscopic dust particles that form the inner rocky planets and form Titan. All of those contained hydrocarbons. And the hydrocarbons can be used as raw materials. They can be mined for like oil, could be mined for make diamonds. You can make steel. You can make basically all this building material for habitats. Also, some of these materials can be actually used for fuel. So we are looking at mining water on the moon and then potentially bring it to Mars. And then we're learning from Mars. So, and then Titan, So Titan does have mountains, sand dunes, a lot of these geologic features that are composed of that rock and ice, and all these hydrocarbons that we can pretty much take all that fuel. Hey, guess what? There's methane in these sands and all over Titan. Guess what methane can be used for? The rockets, the rocket fuel cyclages, the rocket systems. Right there. Perfect for rockets. All the water ice, all the chemical reactions, all of the stuff that you can make rockets out of and power them, and making heat for our habitats. All of this stuff requires a lot of chemical reactions that we can use as a base on Titan that Titan already has. I mean, Mars does have a lot of those materials, but we need to learn from Mars before we even get to Titan. And it's why we need to learn from the moon to get to Mars. But there is some cons to going to Titan. Well, Titan's really far away. From the sun, it's about 886 million miles, or 1.427 billion kilometers. Now, from Earth, it's about 746 million miles, or 1.2 billion kilometers. But its furthest point is 1.05 billion miles, or 1.71 billion kilometers. So that means like the communication between Earth and Titan is about 66 to 90 minutes, or 2 to 3 hour delay. So if there is a subtle emergency, then you will have to wait 2 to 3 hours to get communication back and forth. Now, Saturn's distance from Titan is only about 759,000 miles, or 1.2 million kilometers. Now, if you want to get from Mars to Titan, it's only about 1.45 billion kilometers, or 901 million miles. So if we just literally go from Mars to Titan, that's about 900 million miles to get to Titan. And I said the communication will still take about 2 hours to get from communication to Mars and then to Titan and back. So that is there's a lot of downsides going to Titan. But if we kind of look at the cons, but most likely people are looking at why Titan? Looking at its striking similarities to Earth, its atmosphere, its temperatures, its geography, and most likely all its hydrocarbons that are supporting evidence for life. I mean, who knows? There's exoplanets that we are probably gonna one day explore, but it's just understanding the moon first, Mars second, and then after that, what's gonna happen after Mars, we don't know. People are looking at Titan. So thank you guys so much for watching. I'll see you guys in the next video. And as always, keep exploring.